Let's continue to understand question number 6. An aldoxime and ketoxime on reduction give. So, what are the two important compounds under consideration now? It's an aldoxime and a ketoxime. This is subjected to the process of reduction. Now, this is upon reduction going to yield us. Let us see the different options. Is it going to give a mixture of primary amines and secondary amines? Then, is it going to yield option B, primary amines only? Option C, is it going to give secondary amines only? And option D, tertiary amines only. So, let us look into the question once again and understand in a little deeper manner. An aldoxime and ketoxime. Now, often for a ketone reaction is considered ketones. Whenever we talk about ketones, it's always a secondary alcohol we consider to obtain a ketone. And then for aldehyde, we always consider a primary alcohol. If you keep that baseline and then think this option A as a correct answer, you might be wrong. Primary and secondary amines. Like that, if you think this might be the answer, then that might be the wrong answer. First, let us see what is an aldoxime and ketoxime. I'll explain this in a little deeper manner so that you understand the concept better. Whenever an aldehyde or a ketone, aldehyde or a ketone is treated with hydroxylamine. What is the molecular formula of hydroxylamine? Hydroxylamine. NH2 is amine, OH is the hydroxyl group attached to it. So, both put together, NH2OH is the molecular formula of hydroxylamine. Now, I have written NH2 like this and then OH here, only to simplify the concept. This you have learnt in the concept of aldehydes and ketones, where there is addition condensation reaction between the aldehyde ketone carbonyl group with the derivatives of ammonia. This is that reaction. Now what happens? Aldehyde is treated with hydroxylamine. The product obtained. So H2O goes like this. Then what's that we are left with? R retained as it is, C, and then H retained as it is, and then it is linked with N by double bond and then OH. So this is aldoxime. This product obtained is aldoxime, and with that elimination of water also takes place. In a similar way, the same kind of a reaction is shown by even ketones. R, CO, R dash. I'll make an asymmetrical ketone by writing an R dash. When treated with hydroxylamine, NH2OH, they eliminate molecule of water like this, and the remaining constituents gets condensed. So R, C, R dash. So this region is taken care. Now it is linked with C, double bond, N, and then OH along with H2O. So what is this? This is ketoxime. So we have got our starting material, aldoxime and ketoxime. You can see here. This is aldoxime and this is ketoxime. Now this upon the process of reduction. This, let me just write what happens upon reduction, upon treatment with a reducing agent. So now hydrogen, two of them will combine here, two more here, and then one more hydrogen with this OH goes out as water. So let me write R, then already H is there, one more H, then NH2 will be the product along with one more molecule of H2O. So now let me combine this and write R, CH2, NH2. This is the compound we got. So what is this? This is a primary amine, because nitrogen is linked with one other carbon atom and directly linked with two other hydrogen atom. So it has yielded a primary amine. Let us see what happens this upon reduction by making use of a reducing agent, or we can also use dihydrogen. Here I have taken the example of the reducing agent. So I have written in the equation with nascent oxygen. Let us see how many nascent oxygen is required. 2 with this nitrogen, 1 here, and then for the formation of water, 1 more here. So how many? 2, 3, 4. So 4 nascent hydrogen. If you are writing it as molecular hydrogen, you might write it as 2H2. Similarly, let us complete this reaction of reduction here. This is also subjected to the process of reduction either by treating it with a reducing agent or with a dihydrogen. Now what happens? Here anyhow the molecule of water has gone out. So this OH will react with H, goes out as water, and then 2 hydrogen will take a linkage with carbon and 2 more hydrogen with nitrogen. So they will get linked by a single bond. So R linked with C and linked with R dash, then R is linked with one more hydrogen and then nitrogen with 2 hydrogen along with formation of water. So now you see that we find the presence of 3 carbon atoms. Each one will be, let us say, containing 1 carbon atom, and this nitrogen is just linked with one other carbon atom and 2 other hydrogen directly. Therefore, this is also yielding us a primary amine. Therefore, it is also yielding us a primary amine. You can see that this NH2 and linkage with one other carbon atom is clearly indicating the product formed is also a primary amine. So now how many nascent hydrogen should we be putting? 1 with this carbon and then 2 with this hydrogen and 1 more with this OH, which is going out as water. So therefore 2, 3, here 1, 4. So therefore 4 nascent hydrogen, or else if we are passing dihydrogen gas directly, we need to do this process in presence of either finely divided nickel catalyst or palladium or platinum as the catalyst, maintaining a temperature somewhere between 180 to 240 or 250 degrees Celsius. So what's the product we are going to get here? In both the cases, either if it is an aldoxym or a ketoxym which are obtained by the treatment of an aldehyde or ketone with hydroxylamine, we obtain the aldoxym and ketoxym respectively. This upon reduction by suitable reducing agent or by passing the dihydrogen gas directly, we will be obtaining primary amines only. So what is the answer for us now? Option A tells primary and secondary amines. Option B tells us it is primary amines only. So tertiary amines we don't get it. Secondary amines we don't get it at all. So all these 3 options are not the correct one. So the correct option is primary amines only. So answer B is the correct answer for this particular question of aldoxym and ketoxym on reduction is going to yield us only primary amines.